Now in this video, we're gonna do a quick review problem computing cosine inverse and explain why we chose the range of cosine inverse to be different from the range of sine inverse. Let us start by a super quick review of how we found sine inverse of sine of 7 pi over 6. In the previous video, we have shown one way to find sine inverse of sine of 7 pi over 6. Recall that we started by locating the terminal side of 7 pi over 6, right, on the unit circle. Then we found sine of 7 pi over 6 by looking at the y-coordinate of this endpoint. We know that this is minus 1/2 because this is a 30-60 degree triangle. Finally, we found sine inverse of minus 1/2 by finding an angle alpha in this range, right, such that the y-coordinate of the endpoint of alpha is minus 1/2. And we saw that the answer was minus pi over 6. Remember, the convention is that we will answer in radian. Alright, so that was how we found sine inverse of sine of 7 pi over 6. Now, incidentally, what if I ask you to find instead cosine inverse of sine of 7 pi over 6? Well, let's see. So this angle here is the same. And as before, we see that sine of 7 pi over 6 is minus 1/2. But now we're asking for cosine inverse of minus 1/2 instead of sine inverse. That means that we're looking for an angle alpha within the range 0 to pi, i.e. whose terminal side lie in here, such that cosine of alpha is minus 1/2. So not sine alpha, but cosine of alpha is minus 1/2. This means that the x-coordinate of the tip of its terminal ray must be minus 1/2. So the terminal ray must be either this ray or this ray. Now only this ray lie inside our region of interest, so it must be this ray. But there are many angles with this same terminal ray. We have to pick the one that lies between 0 and pi. So which one is that? Well, that would be 2 pi over 3. So you would say alpha is 2 pi over 3, right, and write cosine inverse of this is 2 pi over 3. Now before we move on, let me ask you this. Why did we decide to use the convention that cosine inverse, the range of cosine inverse, should be between 0 and pi? Why don't we just use the same range as that for sine inverse? Why don't we just use this range? Why don't we use the convention that the angle alpha has to be between minus pi over 2 and pi over 2? Well, let's see. Say we do decide to use this range, right? Then what would be the answer in this case? What would be cosine inverse of minus 1/2 in this case? In this region here, the endpoint of which terminal ray has x-coordinate equal to minus 1/2? Well, as you see, there is none, right? So we want to choose a range such that for each choice of x-coordinate, there is some ray whose endpoint is that x-coordinate. So if we choose this region here, that would cover all the x-coordinate from minus 1 to 1. I mean, of course, we could have also chosen this region here, but it's just nicer to work from 0 to pi. Now let us explain why we chose the range of cosine inverse to be between 0 and pi using the graph of cosine instead. There are infinitely many angles alpha whose cosine is equal to minus 1/2, right? In this picture, I've drawn them as these blue dots here. Those are exactly the angles corresponding to the points whose y-coordinate in this graph here is equal to minus 1/2. Pause and think for a moment if you don't understand why that is. And as we said, for cosine inverse to be a function, we want to have a convention to specify which amongst these infinitely many angles would be cosine inverse of 1/2. And the convention is that we will take whatever angle lies inside this region here from 0 to pi. Because inside this region, there's exactly one angle whose cosine is minus 1/2. Actually, inside this region, there's exactly one angle whose cosine is equal to 1. There is exactly one angle whose cosine is equal to 0. Exactly one angle whose cosine is equal to minus 1. Exactly one angle whose cosine is equal to any number between 1 and minus 1. Thus, it makes sense and it's convenient to define cosine inverse of any number, for example, like minus 1/2, to be the unique angle in this interval here, right? whose cosine is minus 1/2. Of course, you could have chosen other interval, for example this one. The endpoints of their terminal rays correspond to this on the circle. As we said, this is also a good choice because for any number, for example 1/2, there would be exactly one angle inside this range whose cosine is equal to 1/2. In this picture here, you can see that that's exactly 5 pi over 3. Note that you can't say minus pi over 3 because that's not in this range. So there are technically infinitely many possible ways to choose the range of cosine inverse. We could have chosen this one. We could have also chosen this one. And the reason why we chose this range is just because it's the simplest. Now, to check whether or not you understand what we just said, think for yourself, why is it that we chose the range for sine inverse to be between minus pi over 2 and pi over 2? Why didn't we choose it to be between 0 and pi, just like the case with cosine inverse? So think about that, and I'll see you in the next video.